Spring2010-Team2, Team Neural Equilibrium. I'm Henry Diaz. This is Humberto Lopez, our team leader, Pilar, Christina, and Arnold. So basically, the idea for our project is it's a very computer interface. There is a correlation between the frequency of brainwaves readable off the scalp of a human being and their intent in the sense of concentration or relaxation. So for our project, what we're doing is we have two nodes placed here, which Arnold will place on his forehead, and a reference node on the ear, which will read the signals from his brain in a very general state. This frequency is sent into this PCB we created, which is filtering and amplifying it. It's very low signal. It's on the 100 microvolt, like 1 microvolt range? Between 1 and 100 microvolt range, so very, very low and very susceptible to noise. This actually filters it and amplifies the signal, which then goes to this red PCB, which is the Beagle board. It's a small development kit using a chip. It runs off 5 volts and is able to run Angstrom Linux. So it's basically a mini computer. In that mini computer, we hook this up to the monitor, and we got an open source spectrum analyzer, which had the code modified to specifically pick out the frequencies that show whether a person is in what state they are for their EEG. Now the alpha state and the beta state are the ones we're reading. Alpha state is when the brain is generally in 8 to 12 hertz frequency. When you're from 12 to 30 hertz frequency, that's the beta stage. Alpha represents relaxation, beta represents concentration. So reading very generally from Arnold, this is the actual frequency right now. This is the FFT, and there's 2 bar graphs showing the relative strength of each stage, the alpha and the beta. So depending on how relaxed or concentrating is, they will vary over time. So the main purpose of this, separate from being an open source kit, is for entertainment purposes. It could be hooked up to some kind of toy to control, for example, a ball floating on a fan, up and down based on your concentration, any type of device in that sense. But that's for our prototype. The medical applications for brain-computer interfaces are very, very huge and advancing by leaps and bounds. So